Hello everyone, it's Wilson here. Today I want to talk about how to evaluate this integral by interpreting it geometrically. Okay, so if you look at the integrand here, this is actually just two absolute value functions added together. We can graph this one and interpret the area under this whatever graph of the function geometrically, but that's going to be more difficult by graphing this one. I will actually make another video to demonstrate how to graph the sum of two absolute value functions, but that's not the main focus right here. So right now, what we're going to do is to just make things simple. Okay, so what we're going to do is that we are going to use the integral property, which is just to write the two integral. Okay, so by just write this integral as the sum of two integrals by separating this integral. Okay, so what happened is that we are going to look at one of them right here, which is the integrand for one of the integrals will be absolute value of x plus 1. Okay, so that's what we have here, x plus 1. And then dx plus the other integral, which is from -2 to 1 again. The limits don't change, but we are going to just look at the other function. The other function is the absolute value x minus 1. Okay. So now the question is, how do we get the answer for each one? That's going to be simple here. All we need to do is to graph each function. So I have prepared two xy planes right here. And then we find the area that's bounded by the function and also the x-axis. Okay, so let's get started. So first, you know that the absolute value function, so if you just have the absolute value x, what happened is that you are going to get a V-shaped graph that's going to the point 0, 0, which is the vertex, right? That's the origin, and then you have the 1 1, the 2 2, and then the 3 3, and then the -1 1, -2 2, -3 3, right? So that's how you construct the V-shaped curve right here. What happens is that if we have the absolute value x plus 1, that's a transformation. So basically what we're doing is that we are going to move the graph of absolute value x 1 unit to the left. Okay, so so instead of having the vertex at the origin, what happened is that we are going to move that 1 unit right here. So we are going to have the whole V-shaped graph pointing at this spot right here. Okay, so let's just graph it here. So we can plot the points. So what happened is that that's our vertex. And then now starting from that point, we are going to get the other points right here. Okay, so now that's how we get the reshape. And what happens is that we can just connect those points. Then we can also connect the other points. And then we get the graph of this function right here. Now, what happens is that what do we want here? We want the area under this graph. And also the also the region must be bounded by the x-axis. So we go from -2 to 1. So we have -2 starting from here. So that means we are going to just look at, let me see. So look at this region right here, right? So it's this region that we're looking at. Okay, and then going all the way to 1. Actually, no, that's not even the region. That's not even the correct region here, because that's going from -2, right? This is -2, not that one. That one is -3, so I was reading it wrong. And actually, we have just this region right here, and this tiny triangle. And then we go to the 1, so 1 is right here. Okay. Actually, let me just use a different color right here so that I think it's easier for us to just to see. So now basically the integral value, okay, is actually given by the area, the total area of the two triangles. Okay, and that would actually be easy to find, right? So let's just quickly do that. So for this area right here, so that's the base is 1 unit, and then the height is also 1 unit. And then now for the other right triangle, the base it's going to be 2 units right here, and then the height is also 2 units right here. Okay, so all we need to do is to just add them up, right? So what are we getting here? So we are going to be getting what is that? That's going to be 1/2 times 1 times 1, right? Because it's the base times height times 1/2. That will give you the area for this triangle right here. And then what do we get for the other one? This is going to be just 1/2, right? And so what is the other one? The other one is going to be this 1/2 again, and then it will be 2 times 2. So altogether, okay, altogether, we are going to be getting, that's going to be 1/2, and this is going to be canceling those two numbers. Canceling those two numbers, what happens? We are just going to get 2. So 2 plus 1/2, 5/2, right? So 5/2 right here. Yeah, so basically, if we are to come back to the main problem here, the first integral gives us a value of 5/2. Okay, and then plus, now we still need to figure out the second one. Okay, so let's figure out the second one here. The second one, again, we are going to do a transformation from the parent function of the absolute value of x. What this -1 is doing to the original basic parent function is that it's going to move the graph of that function 1 unit to the right. So instead of having the vertex at the origin, we have the vertex right here, and then we still have the same shape of the graph because we're basically just moving the whole graph, right? So we have this one, this point right here is the vertex, and then now getting all the other points. Okay, and then all we need to go from there is that we are going to get this V-shaped graph here. Okay, so we get the graph of this function right here, and now let's look at the regions. So we're getting the region. What happened is that we go from -2, right? So this is -1, -2, so we gotta go from here. So we look at this region right here. Okay, so that's one region, and then we go all the way to 1, right? So that's the region that we're looking at. That's the only region that we want. Okay, so now let's find the area for this triangular region here. This is a right triangle, so we look at the base, 1, 2, and 3. So we get the base is 3 units right here, and then what about the height? The height is also 1, 2, and 3. So we get height to be 3 units, right? So now if you are to find its area, then you're going to get 1/2 times 3 times 3, base times height times divided by 2, right? Multiplied by 1/2, so you are going to get the area for this green triangle here. What is that equal to? That's 9/2. Okay, so basically right now what we do is that we are going to get the answer for this one. Well, we should simply just put 9/2 right here in the yellow color, so 9/2. Okay, now we are actually ready to get the final answer right here. What is the final answer? We have 5 plus 9, which is 14/2 because they have the same denominator. So the answer would just be 7. So the value for this integral is 7. Okay, so that's it for this problem. There is actually a way to do it without graphing the function. We can actually also do it algebraically. I will make another video for that. Okay, so stay tuned. To help me make math learning available to everyone, please share my videos to others and subscribe my channel. It will give me support to make more videos. I want to work together with you to help students and children learn math more easily. Okay, so thank you for watching.